You probably know the principle of protocol stack in networks. Each protocol provides a service and relies on the lower layer to achieve it. The original model defines 7 layers to transport application data anywhere in the world. The Internet has simplified this architecture. That's why we find fewer layers and the numbers are not contiguous. The first 2 layers from the bottom allow binary data to be transmitted over a physical medium or radio waves. Several organizations standardize protocols for this level. Among the best known are IEEE for networks like Ethernet, Wi-Fi, or Bluetooth. We can also mention 3GPP, which standardizes the protocols found in your mobile phone. Each of these protocols is designed to work in a specific environment. Above that, we have the IP protocol standardized by IETF. It allows building a uniform global network by hiding the specificities of Level 2 protocol. IP defines its addressing and routing rules, meaning how to find a path in the network so that by copying information from node to node, we reach the destination. Internet experts like this hourglass representation where IP appears in a central position, but is smaller compared to other protocols. By design, IP is very simple, both to be easily carried on many Level 2 protocols and to be easily usable by higher layers, but also to process data very quickly in interconnection nodes. Above, we find 2 protocols that are only implemented in endpoint equipment. The IP address helps find a machine on the network. Level 4 protocols help find an application running on the machine. TCP is very complex and requires a lot of memory. It allows controlling what happens on the network, retransmitting lost data, and determining optimal transmission rate. UDP, on the other hand, is a minimal protocol that simply routes data to the right application without any control. Above, we find applications that historically are classified in Layer 7. Applications are numerous, but the most common is HTTP, which is used to transport web pages, but also allows direct communication between computers. This diagram shows the protocol stack mainly used in the Internet. We see that at Level 3 there are 2 versions of the IP protocol. Version 4 is the historically deployed version, and it has been so successful that it's increasingly difficult to get IPv4 addresses for machines. To allow the network to continue functioning, a new version was developed. IPv6 makes addressing almost infinite with 128-bit addresses. IPv6 is gradually gaining ground in classic uses, but is especially an essential building block for the Internet of Things. Finally, this graphic adds an additional layer above layer 7 to indicate how transported data is structured with formats like XML or JSON that we will see later in the course.